So we have already started with reciprocating unbalance. And we are not going to go into too much detail as far as how the IC engine works. So briefly, we have introduced this. So Fr is the force required to accelerate the reciprocating part. Here in this case, the reciprocating part is the piston, and that force is given by this equation. This we have already derived in your kinematics of machinery, kinematics of machinery course. That is mass into acceleration, and acceleration is given as omega square r into cos theta plus cos 2 theta by n. That is by Taylor expansion. So only first two terms of the Taylor expansions are considered, and so unbalanced force becomes these forces, that is m omega square r into cos theta plus cos 2 theta by n. And this equation can be compartmentalized into two parts. That is, first part is the primary unbalanced force, and second part is the secondary unbalanced force. Okay, so primary unbalanced force reaches a maximum value when theta is equal to 0 or 180 degree, and primary unbalanced force is given as m omega square r. Okay. And secondary unbalanced force reaches a maximum value when it is at theta is 0, 90, 180 and 360 degrees. So and Fs max is given as m omega square into r by n. So if you multiply primary by 1 by n, that is the obliquity ratio, the reciprocal of obliquity ratio, you will get the secondary unbalanced force. That is the maximum value. So here maximum value for primary unbalanced force is reached twice in one cycle, and in case of secondary unbalanced force it is reached 4 times in one cycle. Okay, so for moderate speed, secondary unbalanced force is ignored, and if you see the direction of the what is it, the unbalanced force for reciprocating unbalance, the direction is same. Right, magnitude is changing but the direction remains same. In case of rotating unbalance, the direction is changing but the magnitude is remain constant. Right, so let's start with the problems on what do you say, the let me just and the question sheet. I have sent the question sheet. Gaurav, have you received it?
Yes, sir.
Okay, I will send it on the group.
Yes, sir. Absolutely.
Okay, okay. So we are going to start with the reciprocating unbalanced problem. So here we are going to see problems on different number of, for different number of cylinders. We are starting with what do you say, two cylinder problem. We start with the two cylinder problem. So I will just read the question. An inside cylinder locomotive has its cylinder lines 0.7 meters apart and has a stroke of 0.6 meters. The rotating masses per cylinder are equivalent to 150 kgs at the crank pin, and at the reciprocating masses per cylinder to 180 degrees. Okay. So rotating is 150, reciprocating is 180 degrees. The wheel center lines are 1.5 meters apart. Okay, so wheels are 1.5 meters apart. The cranks are at right angles. The whole of the rotating and two-thirds of the reciprocating masses are to be balanced. So complete rotating balance and two-thirds of the reciprocating masses are to be balanced uh, by by balanced by masses placed at a radius of 0.6 meter. So balancing masses are placed at a radius of 0.6 meter. Find the magnitude and direction of the balancing masses. Okay, so we have to find the magnitude and direction of this balancing masses. Right. Summarize the data. Let's call it A, that is equal to 0.7 meters. That is equal to distance between cylinder. You have to follow the same procedure, solve the problem on the plain sheet and upload the solution on the assignment. That is the same assignment, homework assignment number 4. So distance between the center lines is 0.7 meter. Length of the connecting dots LB is equal to LC is equal to 0.6 meter. That is the length of the stroke, not the connecting dot, the stroke. So radius of the crank, so RB is equal to RC, is 0.3 meters. Right. M1 is 150 kgs. That is the rotating masses. M2 is 180 kgs. Those are the reciprocating masses. And 2/3 of reciprocating masses are to be balanced. Okay, so this is the factor which gives you the how much amount of reciprocating masses is to be balanced. Okay, so C is 2. The balancing masses A and D, RA and RD, 0.6 meters. Radius of the balancing masses is 0.6 meter. Okay, this for balancing. And RPM is 300. So omega will be twice pi n by 60, so 31.4 radians per second. Just a summary of the same data which I discussed just now. Now, equivalent mass. Equivalent mass is equal to M, that is equal to MB is equal to MC, that is given as M1 plus C into M2. That is 150 plus 2 by 3 of 180. So that becomes 270. Right? So you have to find out magnitude and direction of the balancing masses, that is MA and MD you have to find out, and theta A and theta D you have to find out. So these two things or these 4 things you need to find out. Alright, so let's start with solving the problem. Any questions? Okay, so let's start for solving the problem. So construct this table, and reference planes will be planes of rotation will be A, B, C and D. Alright. So A, B, C and D are the 4 masses. Distance between V and C is given as 0.4 meters. Alright. And distance between the wheel base is given as 1.5 meters. And the balancing masses are located at A and D. Alright. So 1.5 minus 1.5 minus 0.7 divided by 2, so that comes out to be 0.4. So 0.4 from either of the masses B and C, that is the cylinder that is rotating plus MA and MB, MB and MC, that is rotating plus partial reciprocating mass. Alright, so this is the arrangement of the masses. So let's fill the table. So MA is unknown, MB we have just now calculated, it is 270 kgs, MC is again 270 kgs, and MD is also unknown. Right? Radius of rotation for A, it is given as 0.6, And for B and C, we have calculated it to be half of the stroke is 0.3. Right? The centrifugal force will be 0.6 times MA, and this will be 81. This will be also 81, and this will be 0.6 MD, and this will be 0, 1.4. So A is taken as a reference plane, not 1.4, 0.4, 1.1, 1.5. That is the distance of planes B, C and D from A. That is 0.4, 1.1 and 1.5. And so couple will be 0, 81 into 0.4, that is 32.4. And this is 81 into 1.1, that is 89.1, and this is 0.9 into MB. Okay. And also it is given that the masses are mutually perpendicular to each other, that cylinder masses. So if I construct this, start with B, I'm going to start with B, take B as horizontal, so B is this way and C is vertical. Yeah. Okay. So if I draw this, right, so this is going to be B, this is 270 kgs, 270 kgs, and radius of rotation is 0.3 meters, right? 0.3. Okay, those who have finished till this point, please raise your hand. Those who are not
Can you
finished till
lower the screen?
those who are not finished this till this point, please raise your hand. In the chat box. Hello. Hello, those students who have not finished till this point, please raise your hand in the chat box.
Sir, I did. It's not visible for some reason.
Which one?
I raised my hand, but it is not visible.
Oh, it is visible to me.
Okay.
Only one student has raised the hand, right?
Yes, sir.
So only
I
Just
know, sir. No, sir, all have done.
sir, even average no.
Sir,
only
in the
four.
office it is not showing.
Okay, okay. Are you able to see the screen?
Yes, sir.
Okay. Can I continue? Is everybody done with up till this step?
Sir, 1
Wait,
minute share the screen, sir.
How many are still remaining? Please raise your hand in the chat box.
Sir, show that PPT.
All right. So next step will be to construct couple polygon or false polygon. So we have to decide, right? So if you see the centrifugal force column, there are two unknowns. All right, and the for couples column, it has only one unknown. So obviously, you cannot start with force polygon. You have to start with the couple polygon. All right. So I'm going to keep the table and most of the things on the next page. Only this will not be there. So this is not required actually. Now, since you must have already constructed it. So I will just start with the couple polygon. All right. So now you can see these are the two positions of masses B and C. All right. So let's start with CB. So CB is 32.4. This is CB, and it is directed radially outwards towards the direction of OB. All right. So this will be O dash B dash, that is CB, that is equal to 32.4 kg meter square. And next you have to plot CC. So again, so this will be in this direction. So CC will be in the direction of OC, so it will be vertically up. This is CC, so that is equal to 89.1 kg meter square. Right? So this is your point C dash. So join C dash with O dash to close the polygon. So this will be your CD. Alright, this is CD. CD is 0.9 D. Right. So measure CD. Okay, so that is 0.9 CD, that is equal to 0.9 into MD. MD is equal to C dash O dash, and tell me the value in kg meter square. Find out the value in kg meter square. So I will give you a couple of minutes. How many of you are done with the couple polygon? Please raise your hand. In the chat box. How many are still doing the couple polygon?
Sir, what scale did you assume? Was
OB.
You can assume any scales. Say for example, you can take OB, O dash B dash, that is equal to what is this CB, that is equal to 32.4 kg meter square. Approximately take it as 5 centimeters.
Okay, sir. Thank you.
You can choose any value. Doesn't have to be like what I have told. It choose any suitable value. So I calculated this value and I got it as 94.5 kg meter square. So MD, I got it as 105 kgs.
Sir,
And
111.
100 and
7.
107, na? That is fine.
111 111.
That is also okay. And theta D is equal to 250 degrees. Alright. So this angle, take this as the positive x-axis. This is my theta D, and that is equal to 250 degrees. So construct theta MD. This will be D, and this angle will be 250 degrees. Right, so this angle theta, this is theta D. Okay. So you can substitute the value of MD in this column as 105. So 0.6 MD, centrifugal force, that comes out to be 63, and MD is 105. So you can just mention those values in your table, because you will need those values. So this is the couple polygon. And so next you have to construct the force polygon. So you need those values to construct the force polygon. Right. So next let's go and construct the what you say, the couple polygon. So you have got the position of three masses B, C, and D. So let's find out for uh, magnitude and position of A. Alright. So up till this is done. Theta D is 150 degree. Now construct the force polygon. Alright. So forces are A is 0.6 MA. So obviously you cannot start with FA. This is your FA. So this is unknown. So start with FB. Alright. So radially outwards in the direction of B. Alright, so this is OB, and this is 81, and this is BF. So this is FB. Okay, 81, and this is in kg meters. Alright. Then FC, in the direction of OC, vertically upwards, and this is also 81 meter. Right. Next, plot FD. So FD, now we have the value of FD, that is 63. So parallel to OD. OD. So this is EC, this is CD, and this is 63, and join O with D. So this is your 0.6 MA. Find out how much is 0.6 MA in terms of distance, that is vector DO.
Sir, from where we got that 63?
See, MD is 105, na? So 0.6 into 105 is 63. What is that?
63.6 mm. 0.6 ma is equal to 63.
So this comes out to be 63 kg meters. So MA also comes out to be 105 kgs, right? And measure theta A. So this is your positive x-axis, and this is your theta A. So theta A comes out to be 200 degrees. Right. So from construct another mass. This will be A, and angle will be 200 degrees. All right, so that completes the solution. So you got mass A, MA, you got MD, and theta A and theta T. All right, so that is the complete solution.
Sir, hello.
Yes.
Sir, mass A can be in between B and C also, na?
No, it is given. Na position of mass A and B is given. A and D is
Okay.
given. It is in the wheels.
What it is in the?
It is in the plane of rotation of the wheels.
Okay, okay.
All right, we'll go to the next question. Can I continue? The next question.
Sir, wait a minute, sir.
Wait, sir.
Uploading, you can do it at the end of the lecture. No need to do the uploading right now. How many are still doing it? Please raise your hand. Alright, I think only 5 students are doing it. Okay, so let's continue to the next problem. Can I continue?
1 minute, sir.
Alright, let's continue now. Okay. Okay, so we have solved problems on 2 cylinders. Alright, so let's now solve problem on a 4 cylinder problem. Okay, so I'll just read the question. A 4 crank engine has 2 outer cranks set at 120 degrees. So there are 4 cranks, 1, 2, 3 and 4. 1, 2, 3 and 4. So 1 and 4 are the outer cranks. They are set at 120 degrees and the reciprocating masses are 400 kgs. The distance between the planes of rotation of the adjacent cranks are 450, 750 and 600. Okay, so distances between the planes of rotation of all the reciprocating masses are given. If the engine is to be in complete primary balance, find the reciprocating mass and relative angular position for each of the inner crank. So you have to find the mass of each of the inner crank and angular position so that the system is completely balanced. If the length of each crank is 300 mm, length of each connecting rod is 1.2 and the speed of rotation is 240 rpm, what is the maximum secondary unbalanced force? So that is what they are asked, what is the maximum secondary unbalanced force? Okay, so I will just summarize the data. Given data, M1 is equal to M4 is equal to 400 kgs, R is equal to 300 millimeters, that is equal to 0.3 meters, L is equal to 1.2 meter, RPM 240 or 25.14 radians per second. M2 and M3 are masses of inner cranks 2 and 3. Alright, and theta 2 and theta 3 are the angular positions. Alright, so you have 4 masses, 1, 2, 3 and 4. 1 and 4 are at an angle of 120 degrees and 2 and 3 you have to find M2 and M3 and theta 2 and theta 3. Alright, so this is how the question is set up. Alright, so now first step is to prepare the table. We are going to prepare this table. So there are 4 masses, so 4 planes of rotation. So 1, 2, 3 and 4. Okay. And masses are 400 kgs, M2, M3, again 400 kgs. Should not write kg over here. This unit is already mentioned. Radius for all is 0.3. Centrifugal force is 120 kg meter, 0.3 into M2, 0.3 into M3, and again 120 kg. Right. Now I am going to take 2 as the reference plane. Alright. So whatever is on the left hand side is negative, right hand side is positive. So distances from the reference plane are minus 0.45, 0, 0.75 and 1.35. Okay, and couple, multiply these two columns, 120 into minus 0.45, so that is minus 54, 0, 0.225 M3 and 162. Alright, and crank positions are given 1 and 4. This is 1, this is 4, and these are set 120 degrees apart. Right. Any questions till now? The same steps we are repeating. Alright, those who are still doing this, please raise your hand in the chat box. Or you can just drop a comment in the chat box if the raise hand feature is not working. Everybody is done. Can I go to the next one? Can I go to the next
No,
step?
sir, wait.
Sorry, sir, no. 31 students are left.
That hand raise feature is not working today.
Sir, in our device it is working.
Okay, so I am not able to see it. Okay, let me try on my laptop. My laptop. My laptop bit is working, it seems. Alright, if you're done, please lower your hand. Huh? If you have any questions, please ask. If you are done, please lower your hand. Huh?
Sir, why have we taken second mass as a reference plane?
Because I want to see if I take first as a reference plane, then I will get two unknowns in the couple column also, right? So here also I will get two unknowns. And I will get two unknowns in the force column also. So I cannot start the solution in that case. So at least one of them should have one unknown. So take reference plane as M2. So couple of that becomes 0. Alright. So only now, obviously, since you have already asked, so obviously we have to start with the one which has only one unknown. So couple polygon has only one unknown. Alright. And force has two. So you cannot start with the force polygon. You have to start with the couple polygon. Alright. Those who are done, please lower your hand. Okay, so most of you are done. Alright, so I'm going to keep the table on the next screen also. So those who are still doing it, they can refer it. Okay, so now you have to construct the couple polygon. Alright, so this is C1. So we are going to start with C1. Alright, now when you are constructing C1 now, so C1 is negative in this case. Okay, because we have chosen a reference plane somewhere in between. So C1 becomes negative. So since it is negative, this is your O. So O1 is radially outwards. So you have to construct C1 in opposite direction of O1. Alright, so this will be, so if see it is going radially outwards, but my vector is minus 54, it is in opposite direction. So this is my O, and this is O dash, and this is my 1 dash. Okay, so we are starting with the, this is the primary couple polygon. So till now we have not considered any secondary forces or couple. So in this problem we are going to consider the primary as well as the secondary effect. Okay. C2 is 0. So this is your C1 in kg meter square. C2 is 0. Okay, you cannot construct C3, so go to C4. Right. And that is the next crank position. Now C4 is positive, so do it in the direction, draw it in the direction of O4. Okay, so this is your couple C4, that is 162 kg meter square. Right. Once that is done, close the polygon. And this dotted line is your C3, that is equal to 0.225 M3. So measure that 0.225 M3 in kg meters square and find out M3 and theta 3. So now when you are measuring theta 3, you have to take this as positive axis and you have to measure this angle. So this is your theta 3. Alright, those who have already got M3, please raise your hand. So only 9 students have completed it. Anybody who has got the value of this vector C3?
$9.75.
Yes, sir. 9.75.
9.75 what? What did you get 9.75?
kg meters.
Centimeters, sir.
Centimeter? No, I want it in kg meter square.
Okay, okay. Kg meter square 195.
Okay, so I am getting it 196. So 195 is also correct. This is 196 kg meter square. 19. So this is 196 kg meter square. So M3 is 871 kgs and theta 3 is 326 degrees. Right? So accordingly plot theta 3. This is 326 degrees. So from positive x-axis, so this is your plus x, positive x-axis, measure 326 degrees. So it comes out somewhere over here. So this is your mass 3. Right, so this is 3. And this total angle is,
Sir, we are
yes,
getting it 316 instead of 326.
that is fine.
Yes, sir. 315, 315.
That is okay. To get more accurate answers, you can solve it using AutoCAD. Solutions have been prepared in AutoCAD. So. Alright, those who have completed till this step, please raise your hand. Completed till theta M3 theta 3 and a crank position. Please raise your hand. Alright, I will wait for a couple of minutes. All right, I'm going to keep this data on the next page. Let's continue. Now, so next step is to construct the force polygon. All right, so construct the force polygon starting with M1. So M1, so here you have M3 is 871. All right, so substitute that value and construct the force polygon. Point 3. This is 261.3. Okay, so one by one we are going to construct the force polygon. So starting with 1. So here force is in the same direction as the mass. So there is no question of taking that in the opposite direction. So this will be O. So O1 is directed radially outwards. This is my vector. This is 120. That is F1. Right, so F1 is 120. This is O1. Then construct F4. I am going in this sequence. Right, so next mass is F4. So that is also radially outwards. So draw it in the direction radially outwards. So this is also 120 and this is F4, that is also 120. Okay. Next construct F3. That is 261. So this will be your F3. It is 261.3 and then close the polygon. So this is your point F2 is this one F2 and that is equal to 0.3 M2. Alright. So this is the primary force polygon. And so 0.3 M2, it comes out to be 284 kg meter and M2 comes out to be 947 kgs and theta 2, that is this angle, theta 2, that comes out to be 168 degrees. Okay. So construct theta 2. I'm sorry, not this way. You have to extend this line of action and measure it, because the line of action of this vector is upwards. Okay, So extend the line of action of the vector, and this is your theta 2, that is equal to 168 degrees. So draw it along the line of action of the vector. So this is your mass 2, and this angle is theta 2. Right. So I'll put all the 4 crank positions on one page. Okay. So theta 1 is 0, theta 2 is 168, theta 3 is 326, and theta 4 is 120. All right. So these are the primary crank positions. Okay.
Sir, can you please go to the previous slide once? Thank you, sir. You can continue.
Okay. All right. So these are the primary crank positions. Now to find the secondary crank positions, multiply each of these angles, theta 1, theta 2, theta 3, and theta 4 by 2. Okay, so multiply all these by 2. Okay, so that will give you the secondary crank positions corresponding to secondary unbalance. So this becomes 0, this becomes 336, this becomes 652. So 652 minus 360, so that becomes 292, and theta 4 becomes 240.
Can you repeat?
See, this becomes 0. This is so these are for secondary. Okay, for secondary crank positions. So these are the secondary crank positions. So to obtain that, multiply the primary angles by twice, by 2. All right. So this becomes 0. This becomes 336. This becomes 652. So it is greater than 360. So subtract 360. So that gives you 292, and theta 4 is 240. Right. So these are the corresponding crank positions. So I will just accordingly plot the secondary crank positions. Now I am going to the next slide. I am keeping all the angle data same. Just note down theta 1, theta 2, theta 3, and theta 4. Right. So keep all the crank positions same. Okay. So these are all the 4 crank positions. Okay. Now we are required to find M3. Okay. So no, we are required to find the secondary unbalanced force. So we have found M2 and M3. So M2 is M2, M3 is 871, and M2 is 947. All right. So multiply this by 0.3. So 0.3 into 871, that is 261, and 0.3 into 947 is equal to 284.1. All right. So now you have all the forces. This is F1, this is F2, F3, and F4. All right. So now construct the secondary force polygon. Secondary force polygon. All right. So this will be F1 120, F2 0.3 and 2, F3
Sir, please
point
wait. So please wait.
M3 and F4 is again 120. Right? So 120, 284.1, 261 and 120 degrees. All right, and complete this force polygon. That is your secondary force polygon. All right. See,
So what is the value of get?
I'm going to repeat the last part of the problem in tomorrow's lecture. I will repeat it. So don't submit if you are not able to complete the second problem. Just leave it. You can submit it tomorrow. Okay, because already we have passed the lecture time. So small part of calculation is remaining. So that we'll do tomorrow. All right. So I'm going to repeat it from this. I will repeat the whole part from this slide, so that because it is getting rushed, it is becoming too fast, so some students might not be able to pick it up. So let's stop for today.
Sir,
Yes,
what is the value of M2 you get?
M2 is 947.
Okay, okay.
All right, so I'll just quickly take the attendance. Hold on a minute. All right, you can leave.